To verify these are inverses, we need to use function composition and essentially just plug each function into the other one. So first, we want to plug the inverse into the original function. So what that means is we're taking all of g inverse of x and plugging it in for x in the original function. So we take the cube root of x, replace the original x with it, like we just did, essentially in those parentheses, and then the original function is that cubed. So now, just really quick, simplify that. When you have the cube root of something and cube it, those cancel out, and you just end up with x. So that means in one direction it worked. Now we have to do the other. So we have to take the original function and plug it into the inverse function. So we take x cubed, put it in place of x in the inverse function. So we have the cube root of x, and then we're plugging x cubed in its place. Again, the cube root of a cube cancels out, and you're just left with x. Since both of these are left with x, it is inverse. And the whole point of it inverse is that it undoes the original function. So all the extra bits are canceled out, you're just left with x. So this is the same idea again. For this first part, we're going to take the inverse, all of that function, plug it in for x in the original. So the original function had a 2, and then we're multiplying it by the inverse. So that's where x was in the original, and then the plus 3 is on the outside. Now it's just a matter of simplifying. 2 times 1/2 cancels out. So we're left with x minus 3 plus 3. Minus 3 plus 3 cancels out. So we're left with x. Same thing the other way now. We take the original function, plug it in for x in the inverse. So our inverse function is 1/2. Now we need to replace x as 2x plus 3, the rest of the function. So for this one, this time first, the plus 3 minus 3 cancel out. So now we have 1/2 times 2x. 1/2 times 2 is just 1, so those cancel, and we're just left with x. So yes, these are inverses.